देखो साउंड सिस्टम देखो बोल नहीं रहे कुछ सबके अलग अलग हो गए नीचे रुको नोट कर
Good afternoon, everyone. On this, all the participants, I welcome all the participants in the 17th online webinar, Aushad Jigyasa, discussion on drugs with legend. In this regards, I would like to call Dr. Shobna sir to welcome our guest of honor.
Hello.
Audible.
Very good afternoon to all of you. Here with warm greeting, give me grand pleasure to extend warm welcome on the behalf of the Department of Bhaishajya, Kalpana, Dravyaguna, and Agad. Conducting a weekly webinar series discussion on drug with legend topic cutting and its technique application, its interpretation in Ayurvedic medicine. As a resource person, Dr. Jayanta Kumar Maji. He is presently head of department of QAQC IUCAL, UP Pharma Ahmedabad, and ex experience in research associate SRI SIT and research fellowship of Nirma University Ahmedabad. Welcome you, sir. I also welcome to Higher Authority of Ministry of Ayush and welcome to our VC sir, HOD department, all the HOD department of the Rasashastra, Bhaishajya Kalpana, and DG Dravyaguna and Agad. Otherwise, the continuous support. Continuous support for the webinar series. Welcome to you, sir. I welcome to all the staff and student and the PG scholars for the today webinar series. Thank you.
Thank you, Shobnath sir. Actually, Shobnath is my colleague also. And just I am, this is the time in now 3:36, 15:36. That's why I just quickly share my desktop just here. Just I here. This is the actually in that webinar session, I just explored the cutting edge technique, the application interpretation of Ayurvedic medicines, and both herbal and nanostructure based bhasmo. Myself, Dr. Jayanta Kumar Maji. I am the now HOD and QAQC of ICOL PUP Pharma, and as a research associate at CIST, and then Ayush Research Fellow at Nirma University, and previous ex lecturer in IPGTRA, Gujarat Ayurvedic University. And actually, my that webinar is cover of these various content as a nanostructure based Ayurvedic bhasmo and roadmap of bhasmo characterization and physical and chemical characterization, safety and efficacy study, both in vitro and in vivo, and herbal drug standardization and phytochemical analytical standardization. With 1 hour, I just cover up the, but this is not a vivid, so that's why I'm going to the actually nanostructure based Ayurvedic bhasmo. According to Ayurveda, these all things which exist in the world can be used as a medicine. I am just going to the Ayurvedic bhasmo. This is the oldest bioenhancer in bhasmo. Now the Pipali is a bioability enhancer, but previously Rasindur, gold, and low. This is a they're also the bioenhancer in bhasmo. And basically, in Ayurvedic practitioner, they are believe that the that bhasmo preparation during that is the cover of purification and jaron and maron and amritikaran and loitikaran. This is the tedious process, and that their belief is the specific therapeutic properties and as well as removing the toxicity of the metal and facilitate the absorption through gastrointestinal tract. And here the quality of bhasmo actually studied needed the systematic characterization of the samples, various morphological, structural, and elemental and chemical characterization also needed. And this is the roadmap of the Bhasmo characterization, because nowadays Bhasmo is the new window. This is a physical characterization, chemical and visualization. This is a complementary technique, and classical physical and classical chemical, and also toxicity and in vitro cell line study, and also now in that era that is needs again clinical study. And actually, I just classical physical test also during Bhasmo is preparation. This is a in-process quality control, and also the finish test. This is a very thorough test, and everybody know the traditional practitioners. And when Bhasmo is the floating the undisturbed water, and they don't break the surface tension of water, they are very fine. But nowadays, not every fine Bhasmo is not present. That's why that Baritoro Bhasmo marketed sample is failed. And that Unam, this is when grain of paddy is floating up the Baritoro Bhasmo. This image is the here is same. And Rekha Punatta, this is actually the furrows the finger in enter. And Nirdhum in smokeless, because various now multiple butane flame are also this apparatus here image is seen. You can the taste of the Nirdhum smokeless, and some gritty particles flings between teeth when the
Excuse me, sir.
that taste. Yes,
सर स्लाइड शो नहीं हो रहा है सर.
the नहीं हो रहा है.
नो सर.
Now
नो सर.
now now this is third slide, classical physical test.
सर आई गेस आपने शायद स्लाइड शो ऑन नहीं किया होगा. जस्ट click on the share screen option into the Microsoft Teams and then select the option entire screen.
Already saved. Now
No sir, it's not there. You can log out and join again. Yeah, I guess it is. Yes sir. Now we can see your screen. फिर से चला गया.
again click. Wait a minute. Click there. Also click share. No, don't stop. Go to our desktop. Okay, now this is a classical slide number 5 seen.
Yes sir.
Okay. Actually, just there is some classical physical test already I mentioned. So this is the 1 hour that I am carried forward, and actually their cutting edge technique, their dynamic light scattering. This is a particle size distribution technique. Why that technique is very good? There is no need for the calibration of this particular instrument. You can directly analyze your samples. But in the particle size distribution in the Bhasmo physical characterization, this is a nowadays is troublesome, because you cannot copy the modern instrument. They are export their evolutionary stage, but our samples sometimes not match the sample preparation is most important factor. And that's why just I going to the dynamic light scattering. Everybody know when particles in aqueous media, they get the undergo random motion, that is like a Brownian motion, and that when beam of monochromatic light is hits the particles under random motion, and some portion of the light gets scattered. That scattered photon is basically reaching the detector, and this is the dynamic light scattering. The zeta plus analyzer are used. And here one thing, see the this is the image of this schematic diagram. Just I don't give these basically instrumentation, just I carry forward. And an argon laser is the light source. That laser must be 600 nanometer producing light. This is the essential. And that instrument actually measured the intensity of this laser light with the particular angle after interaction in spherical shape particle which is suspended in aqueous media. And that hydrodynamic diameter of the sphere, every particle you will imagine as a sphere, was measured in autocorrelation function. Sometimes this intensity of scatter light, actually same particles when smaller than the wavelength of incident light, you can see the 600 nanometer. That is a Rayleigh scattering. Just based on Mayer theory, the light depends on the angle particles greater than 250 nanometer. And that is a photomultiplier tube is a detector. And fluctuation of the intensity, which time gives the diffusion coefficient of these particles. Actually, here I just briefly, actually, when the particles in aqueous media, that particles undergo the random motion, and that motion with the laser light being the their constructive and destructive interference because two adjacent particles, and that particles give the total intensity with the equation of the help of the Stokes-Einstein equation, and where D is equal to KT by 6 pi eta and R. Actually, D is the diffusion coefficient, R is the particle of the radius, K is Boltzmann's constant, and T temperature, and this is the shear viscosity. This is the viscosity of this solvent. Here it is aqueous. Here just how the interpretation is realist technique. Because why? The Bhasma is very fine particles. Everybody know the 0 to 100 nanometers. You can be, this is a immunomodulator. But there, our aim is 0 to 100 nanometer must be qualify our Bhasma. But basically that is not possible. This is another issue. Here just one give. This is a gold Bhasma particle size, and that particles in aqueous media when Bhasma, sometimes that Bhasma is a physical test. You are not, there is a floating of the very fine, there are floating. But here you can, the sample preparation, either the sonication is needed. And after sonication, you can find 10, 30 minutes, 40 minutes, 50 minutes. That sample preparation in your sample is Bhasma preparation instrument, that's qualified. But how the DLS technique data in your published articles? Here is a PDI. Polydispersity index must be 0.03. Then your published articles give your published your data. And here the size of the dimension of the particle size and percentage of intensity and standard deviation of the particle size. That data is needed for this when the publish of these articles of the DLS technique. Here next, here is the Rasha property. Their particles also going to the vary. This is the cumulative distribution. The first one is the bell-shaped curve, but that curve not is a bell-shaped. And here is accuracy of this particular controlling the refractive index. If anyone can think about, I am not as a aqueous media, I have used as a very viscous, as a honey media. That is also possible. So in that way you can develop in your method. And sub 100 nanometer measured is also possible. And concentration you can prepare here. Basically everywhere articles 10 milligram per ml. That is also DLS technique. Another is a bait analysis, because physical method is a cutting is a technique. Because when your particles is very fine, everybody frankly says Bhasma is a large surface area. But reality, that surface area is match your hypothesis, because that's characterize the porous of fine dispersed solid. You can, that technique is a gas adsorption appropriate method. That adsorption amount of gas depends on the gas pressure. This is the mathematical sidebar, and you can that in that equation you can address the amount of absorbed gas when built on monolayer on the surface. Means that particles are give the nitrogen gas or krypton, that type of any gas, and that adsorption isotherm, how they adsorb, and that adsorption disruption is happening. In that way you can measuring the isotherm, and that amount of molecules, monolayer, sometimes multi-layer also happen, because your Bhasma not a pure gold Bhasma. Sometimes there are various cocktail environment. So there are another element traces also present. So in that, and this is the instrument, nice instrument. You can data collected in this automation, but which plots the amount of gas absorbed as a function of relative pressure. Here is the, that is a, you are published your articles, and you give that Bhasmos particle. This is an isotherm graph. In that graph, you can see the BAT range, means that is a pressure versus the relative, that bait region, bait range. You can that bait range. This is a linear range, and another that is not a linear expansions. So in that way, your pore size maybe 1 to 10 nanometer, or mesopore or micropore. You can, here one is article, their Abhrabhasma, that Abhrabhasma is basically in Dhanabro. They are introduced that Dhanabro preparation, because classical method, there is various tedious process, you get the maximum quality of the Bhasma. So in that way, they publish their surface area, pore volume, and maximum pore size, and average pore size. And they also publish marketed sample. The marketed sample, they are varied. So in that way, academic institution, they are build their real-time gold data that which are monitoring the industry. And now I am going to the most important cutting edge technique in our field. It is basically in Bhasma, XRD, X-ray crystallography. And actually, everybody know these. Assume atom are actually arranged in periodic pattern of the 3 dimension. According to Moseley law, the every characteristic X-ray emitted by Moseley law, every atoms emitted one particular characteristic X-ray, and here energy is less than used. And Bragg's law, and this is a mathematical side, but Bragg's law, everybody know n lambda is 2d sine theta. Just this is a 12 science logic. Actually, when incident lights and they light pass through the particular one media distance, and then this is a diffracted X-ray. So in that way, I am just going to the this is the instrumentation. Here, this is the primary X-ray source that are moving, and second is this is a sample holder that is stationary and is a diffracted beam. And this is a powder X-ray diffraction instrument. That instrument our need for the Bhasma, because our Bhasma basically in very fine particles. I just interpretation with the XRD. This is a beauty if you are learn, because this is a 3 and 52. Actually, that's why this actually this is the graph. That is a 2 theta degree graph, and this is a count. And you can check there is a prominence peak, and the position of the peak you can value the 2 theta value. A large number of peaks, you can get your Bhasma material decrease symmetry, not a uniform. You can just general observation, and distinct peaks simply distinct peak, that is simply in crystalline nature of the sample. And peaks are actually, there is self-centered, body centered, face centered. I am not the structure atom. And a higher intensity suggests the arrange the particular plane. That plane is the 3 dimension HLK. And you can just XRD interpretation. This is a nice, basically XRD. You can share formula. You can here use the crystalline size of this particle, and with that equation d is equal to k lambda by beta cos theta. This is the crystalline size. Should be unit is nanometer, and k is constant here. When crystalline shape is 0.89 to 1 k, and 0.9 for homogeneous, and heterogeneous 0.89. So in that way, and lambda will be the X-ray, that is a 0.154 nanometer, and beta, this is a full length of maximum peak radian in radian unit, the beta, and theta is the half corresponding peak angle. Which previously you see that that is a 2 theta, so just half the theta. So in that way, you can the crystalline size measurement. And XRD interpretation, you can, with the help of the expert high score software, first your data must be matched, particular because every periodic table element, their XRD pattern are already available in International Center of Diffraction Data. And that peak position, particular that 2 theta, you just resembles what is the peak position and find the origin of software, because when you take the sample and there is some software dependency. And just I'm going the, because this is and how the interaction XRD spectra interplanar distance you can calculate it, and that is just mathematical sidebar, you can easily calculate it. And the final, how the lattice distance, because these documents are needed in your published articles, this particle size, lattice constant and Miller indices, and this is that 4 slide you can explore and you can easily calculate it. And with the help of some 2 software, when you this sample analyzes your particular sample, they give that type of 2 data, just remaining processing are needed. I am going, and this is XRD peak pattern, because sometimes some articles their gold bhasma is a 4 unique peak, but our Ayurvedic practitioner, they are believe the bhasma is sometimes an oxide and lead oxide and lead sulfide, nag bhasma, that is a silver oxide and silver sulfide. But actual that there is sometimes match is needed, because you just one type, I just XRD, I don't practice the interpretation skill, just I reported this is a status report, because you cannot that work. So that's why XRD pattern here is a X-ray diffraction pattern of the Rajat bhasma, and on as a standard silver sulfide and silver oxide and Ag2O3, and another is your the common peaks between the bhasma and silver sulfide, they are indicated, and the bhasma silver oxide indicated the asterisk. So in that way you can develop in your database of the particular bhasma. And I just classical and chemical test, I can cover up the physical test, just everybody the Apurna Bhava test. This is a Mitra Panchak, you can add it, it did not again original state. But in-process quality test bhasma endpoint nowadays not validated, optimized still late. But that is the good parameter. If you are applied the design of experiment QBD, because you according to Jadavji Tikamji, they are explained when you prepare the bhasma and ropo and gold, their heating pattern is different, low to high. And when you are the abrak and iron bhasma, their heating pattern high to low. So in that way, every bhasma that is the unit. And another way, in classical, in gold, BBR, Bharat Bhaishajya, there is 20 Maran process. And another also beauty, there is no mention in the batch quantity. And another also things there is needed for the work. When you batch size increase, your heating pattern also different. You cannot follow the classical parameter. So this is my 3 years industry experience, and this is a classical chemical test. This is a Nirutho. I am don't get, and just Nammuri phase pot test. This is actually reference Dr. Nammuri H application. Actually, this is a CCRS New Delhi. And now various bhasma there give first phase, second phase, third phase. You can just chemical reactive paper are used and solvent reagent are produced the sample preparation, and that the end point of this particular came to yellow for a Rajat bhasma, and Tamra bhasma is chocolate color, and purple to light pink in Sudha Varga bhasma. So in that way, and just here I gold bhasma here in our lab, the Swarna bhasma according to Roshamrit method, and I'm going to the classical gravimetric test also done. You can low bhasma. CCRS limit is low bhasma is 50 to 70%, and Kashis bhasma is 30 to 40%, and Mandur bhasma 35 to 55%. But another beauty, if you are that bhasma is magnetized. Now, in Indian market, there is another notion because some company there claim my bhasma is not magnetized. If you are prepared in your academic window some bhasma, there is that beauty also happen. Why magnetized? And I just also some books also there. They are also mentioned, but just this is a titration method. And actually now the most chemical assay is the cutting edge technique, ICP OS spectral analysis and gold bhasma containing commercial Bharat Chintamani Indian market. I just post marketed surveillance according to just I supplied the Aikal, Badana, Drabar and Dhut Papeshwar and Jhandu. You can check their level claim also is different. Level claim is different. And I inductive coupled plasma optical emission spectroscopy. You are the element composition in composition. This is a high accurate precision, good correlation. Then AS atomic absorption spectroscopy. And also ICP is the more precision. But ICP is because sometimes your bhasma is a large amount trace. But here is I just compound formulation. And Subarna, Prabal, Mukta, Rajat, Abhrag, and Loho Rasindur is various parted. I just this is the just gold concentration there vary. Just because every Biyadbat Chintamani, and just how the bhasma molecule of digestion technique is needed, because your bhasma sometimes Rasindur also present, various Sudhabarga bhasma also is present. So in that way, I instrumentation I am not going the ICP OES. But one thing, if you are your data must be reproducible when you prepare that Biyadbat Chintamani or Basant Kusumakar Rush. This is a and Basant Malati Rush, and that is the compound formulation, and there is that is the ICP OES, the linear range at first established. Here I am established that particular element, and that is a lambda, and that is a calibration range, that correlation, and this is a limit of detection, and particular that formulation, this is the linear range at first I established. So in that way, my method is established, then I am qualified that method. Because, and here is the chemometrics techniques I applied, because now that technique is in herbal, and this is a previous technique, but in our traditional system, this is the most important technique. And that here is, you can see there is a magnesium, lead, aluminium, and heavy metal, arsenic, iron. Drabar Badanath give this another position. They are another level, and I call precious and I call premium the another dimension. Dhut Papeshwar Jhandu another, and so in that way you can check there is in marketed BBCR, there is a four type of BBCR, Biyadbat Chintamani, because their elemental composition is different, but their reference is more or less same. How and you can check this is the two company, and this is Aikalp, and this is Aikalp and Jhandu, and this is Drabar and Badanath, this is Dhut Papeshwar premium and standard. So in that way, here market is 5 different codified Biyadbat Chintamani. I can just supply just one technique, ICP OES, because you sometimes our scholar and they are frequently use various technique. If you are in particle size, you can going to the bed and XRD and also DLS, anyone, and then you are a quantification that ICP OES. There is no need for the another ornamental technique. I just touch. This is a visualization. This is a ornamental. Just paper there, just give the good graph. But there is another. This is atomic force microscopy. You can use this. That also ornamental. Certain tapping mode Ayurvedic bhasma, because that microscopy there is basically used in medical science when the pharmacokinetics and the tissue level analysis, toxicity study. But here characterization is not you can blindly use. Tapping mode in Ayurvedic bhasma You can just get the 3D image high resolution, and just here 10 mg sample you can just cover slip, and then uh, the exact position. Actually, this is the most important, how the three dimension. This is a cantilever and tip, and this is the page Z scanner. So in that sample surface, that is the tip are just movement x axis, y axis, and z axis, and detector give that particular data. So in that way, this is the your Sarnabhasma data. The three dimension you give this particular, and there is, if you are a that data you are in articles, this is status report. Here that data must be needed, how the roughness, how the average roughness, because you give that image. So that calculation is much needed. I just going the ACM PM. Sometimes your sample is not qualified DLS, XRD, you not satisfied because particle size is different. Your hypothesis is 0 to 100 nanometer, but reality that is different. So in that circumstance, you can just touch if any instrument you qualify, just support your argument, support your hypothesis. So that way, just scanning electron microscope, there is limitation. If your sample is conducting specimen, then you cannot use the TM. If you're a non-conducting specimen, ACM also used. So in that way, energy dispersive express, this is semi-qualitative analysis. If anyone use that data, EDX is a costly instrument, I just blindly use. If you are use your characterization particular final product, you can little bit information. And FTIR, actually, FTIR is an organic zone. This is the most important. When you prepare the bhasma, there your belief there is anything present. If water molecule, weight, moisture, there is no organic molecule high present because they are not as form. And thermogravimetric analysis, you the heating pattern you can just that is a practically and theoretically that bhasma you can check. So in that way, just I cover up the various other instrument, and that is not possible, that time can use. And another is the toxicity. This is the most important. Safety is the most, because if you are a new bhasma prepare that is not previously published, it would have acute toxicity, then subacute, then subchronic, and then more than 90 days. This is a chronic toxicity also needed. That is a various OECD guidelines. But in our CCRS guidelines, they are give the safety and formulation development. There is no mention basically in bhasma, no in vitro. This is this is needed, because in vitro means your genotoxicity you also perform. Your bhasma is genotoxicity, but their CCR is not. And personally, some scholar and some academician, they are true Ayurvedic hardcore lover. They establish that their sample is the genotoxicity, and cytotoxicity also, and carcinogenicity and neurotoxicity. Actually, Biharbhat Chintamani, some group of scholars, they also perform the neurotoxicity. So in that way, that toxicity is the most important part. And now the efficacy of the, because everybody now are going to the cell line. Our bhasma is qualified cell line. Actually, here just Ayurvedic is a new chemotherapeutic agent. If you are because Ayurveda is a host machinery to rectify disturbance in cellular physiology and restore homeostasis. This is the Ayurvedic beauty. According to basic science to need well-tolerated, low toxicity pharmacological agent to treatment regimen and invasive and toxic intervention. But metal and mineral actually biochemical process controlling major cellular major activity in cell metabolism, cell division, and actually cation and minimum level of iron, zinc, and copper individually and simultaneously synergistically and alter the cell metabolism in cancer cells. So in this above formulation, actually Ayukalpa, our company also Cytoquel capsule and tablet, their practices and their they also their minimum distillation of traditional logic the herbomineral formulation prepared, and they standardize subacute, acute, and MTT reduction assay, and they also cell line study. Just like this is the cytocoel composition, this is acute, subacute, and just like carry forward in the in vitro anti-cancer activity. This is a cell viability MTT assay, and there's these cell lines MD, MD231. This is a base cancer cell line, and A549. This is that cell line is the alveolar, and this cytocoel capsule. This 2 mg per ml. That is the dose are taken, and that media is taken, and incubator that is conditioned, and they give that particular activity. The cell viability means cell metabolism activity. And just here you can just, this is the doxorubicin is a standard drug and cytocoel, and doxorubicin is the green and cytocoel, and more or less you can say this is a disease cell line decreasing pattern of the cell viability. So in that way, cell line also your Bhasma, because one thing you cannot, your Bhasma is not a modern oriented samples. Your Bhasma is at first you quality establish, then sample preparation. This is the most important for traditional science. That I am going to the herbal medicament actually. Actually in herbal, they now herbal sector, they are also in food sector. But or so in that way, sometimes I just in vitro test with the in vitro cytokinases block micronucleus assay. This in vitro test also needed. Just I actually prepare sterile leaf extract, Bambusha aurundinacea, everybody know. Just 10 gram powder, refract 1 hour, evaporated till 10 ml. Then just that extract in series filter, and bacterial resistance series filter must be hooked, and check the sterility of the extract. The extract sterility, because I am going to the in vitro test, and this is the sterility outcome. They are agar in 72 hours, and there is leaf extract. There are no bacterial growth and no fungal growth. So in that way, I am just going to the blood collection, the non-smoking healthy donor. Actually, they are more or less 20, and that blood sample are collected from cubital vein if you are a doctor, and blood is collected in sterile heparinized vagutainer, and that blood and gamma radiation treating with the gamma radiation given. When gamma radiation is actually cell division in prophase, metaphase, anaphase, and telophase, I just gamma radiation and give that is a RBC. I just RBC analysis here, and I just also take the leaf extract 30 minutes, after 30 minutes. And this is our experimental protocol. Always negative protocol is needed. Positive protocol, negative protocol, and test protocol. If your data take that time research tenure, that is not possible. You can just one dimension, that work must be reproducibility. If anyone claim that work is very good, that your time tenure, your MD time tenure, at least one dimension you give the 100%. That data must be reproducibility. That is needed for the Ayurveda. And this is the experimental setup. Just take 1 ml blood, and that media incubation 37 degree. Then cytochalasin. This is one, because your metastasis metaphase process you can just arrest it, and then incubate 46 hours, and after this the cell harvesting, I just cell harvesting, and then after staining and slide, you can just scoring the nuclear division index, how that is a monocentered, binucleated, and multinucleated. This is the binucleated cell, multiple micronuclei, and this is a Bambusha aurundinacea, actually micronucleus frequency and abbreviated cells, and blood and radiation. Actually blood irradiation in 90 microgram per extract. This is the highest important, give the gamma. In that way, radio protector. Actually our herbal sector also is a natural radio protector, because cancer there is need the herbal sector. In that area, if any Ayurvedic formulation, that combination is very good. And you people, this is translation research. You just going to the in vitro CBMN assay. And now I am going to the most important, the analytical technology, because HPTLC and HPLC in academic institute level is compulsory, because this is the two basic instrument. If you're that instrument, you can also check, because one thing, natural product chemistry is really not a easy task, because you cannot be control the nature and you cannot be control the geographical distribution. If in Indian various dimension, ashwagandha is different, Andrographis paniculata is different, and India is the second highest of the bamboo. The Bambusha arundinacea, Bambusha vulgaris, and various species are available. And here, just to at first one question, you even when your sample is analyzed, at first you method development your method according to ICH guidelines. You are not method validated, because if anyone your cited your article citation, and that they are used there as a method, because they are working in another area, just they cite your articles. If that is not reproducible, that is really scientifically flawed. So that's why when you minimum data, that must be inaccurate, and that is needed. Here is chromatography. 4 phenolic acid is established. This is a chlorogenic acid, gallic acid, caffeic acid, phenolic acid. This is a TLC chromatography. You can easily separate it. This method is developed. Then you can, that is method development, linearity range and confidence limit in that set. So in that parameter, when you give your articles, then that is good, because that method is established. And this is, you can the extract particular marker in raw powder. Means if anyone Bambusha arundinacea, that amount, that their resembles their chlorogenic acid, gallic acid also, that solvent system, you can produce that 4 marker. You can retain toluene, ethyl acetate, formic acid and methanol 3:3 0.6. If your sample is that 4 phenolic acid, that give the prominent peak. So in that way, that solvent system is the most beauty if anyone. And now the HPLC, because why HPLC and HPTLC is a planar chromatography, adsorption. Here is partition. Actually, sometimes polyphenol and flavonoid, they are slightly more or less not same, because 230 to 280 nanometer range they are participate. Because here is 8 marker are established. Previously in the HPTLC4, here is 8 marker, means 8 marker component, means this is phytochemical metabolite component present in your sample. If in that method at HPLC condition, their chromatogram 8 marker chlorogenic acid and isobutexene and lutein, epigenin, that this is the validated. If that validated, you can establish, then that method must be. And here you can the various 3 species, they run the particular, you can easily that standardization the particular component, how their various marker is the 3 bambusa species. Because everything is bamboo, sometimes pharmacogoners, they are identified, they are taxonomies, but one time why is superior is bambusa arundinacea, you can see the whole marker is covered up, but here sometimes in bambusa vulgaris and dendro, that is missing. So in that way, I just completed my presentation. Actually, I recently published the Ayurvedic Bhavna process in Frontier in Pharmacology journal. This is our team, Rohit Sharma and the one CCRS guy, and also PK Pajapati. The Ayurvedic Bhavna process is that also on a Guruji, you get Bhavna, and that if you know the synergistic and you know the antagonistic, and here I concept added the supraadditive, because when you can Bhavna, then supraadditive, because that in that way that Bhavna concept that also published in Frontier Journal. This is the 4 marker, and actually this is another journal, near infrared spectroscopy, means non-destructive instrument also is needed for in our Ayurvedic field, because if you are in Dravyaguna department and botanical NIR instrument, you can just go into the Himalaya region, just NIR, you just non-destructive, cut down the image. So in that way, you can Himalaya region, how many species is chemical races is present, you can easily classification with the help of the various chemometric techniques. I just cover up that 10 minutes for if anyone any question for this particular presentation. Hello.
Thank you, sir. It was so knowledgeable to hear from one among the finest legend on the topic. Now stage is open for the question.
Namaste, sir.
Yes.
Sir, I have a question.
Yes.
Basically, there are 2 questions. First is, what are the test or analytical methods by which we can identify calcium compounds in different bus of Sudha Varga? And second one is, at the final stage, all are the same or different?
Now, actually, your voice is echoing. Please just clear your voice, and you can question in one by one. You can just first question your I don't got it. You just
Okay, sir. So my question is, what are the test or analytical methods by which we can identify calcium compound in different bus of Sudha Varga?
Okay. Actually, the different Sudha Varga means sometimes you can just at first you search the articles, because there is numerous articles in acute, subacute toxicity, and also trace element and analysis also they are present, because you just at first where previous researcher missed that point, you can gap that research point. And here another in a question, which instrument is the most important? Okay, actually you can just follow the your bhasma in confirmatory. Some in our physical classical test, if that bhasma is really qualified, then you go to the external analysis. So in that way, you just go through the XRD and ICP-OS. There is a 2 instrument. There is no need for the another instrument. Okay.
Okay, sir.
Second question.
Sir, actually, sir, at the time, actually, I wanted to ask you the actual what is the compound form of, in which compound form
Yes.
that chemical is present in
Yes.
the.
Sometimes some scholars say this is a calcium oxide. Sometimes if you are a calcium oxide, and sometimes cassiterite. So in that way, there is a nothing but a oxide. But that this is a oxide form. Actually, Sudha Varga in this is a oxide form. This is a sometimes CaCO, 3 means CaCO. In that way, you can just subdivide it, because you prepared your bhasma is not a properly. You cannot get the 100% CO. You can go through the EDX, and there is little information, but that is a semi quantitative. What compound that formation? Your question is good. What compound formation? We know the process of the various SOP and finished product. What compound? This is your hypothesis. You can search the, and I just help XRD and EDX and ICP-OS, that 3 instrument, you got your answer. Okay.
So my second question, I have got the answer of second one also. Thank you, sir.
There's one question from a scholar, Dr. Rishabh wants to know of your view on phytochemical authentication for quality of Shuddha Shilajit.
Shuddha Shilajit.
Yeah, sir. He wants to know the phytochemical authentication for quality of Shuddha Shilajit.
Actually, if you are a Shuddha Shilajit, there is a need present is fulvic acid. There is a major amount fulvic acid. But now that fulvic acid, if anyone synthetically added, and because Shilajit, this is a controversial drug, and now Indian market Shilajit are prepared in various form. Sometimes black Shilajit, someone is a red color Shilajit. So in that way, you can at first take your sample. Who is your authority? Authentified your sample. This is the first sample. This is a Shilajit. So you just capture various region. If you are a traditional the Nepal region, you can just collect in your excursion. You can. This is the controversial topic. You can search the all marketed sample, and according to my question, this is fulvic acid. You can. This is the chemical, but there also need if anyone mix the fulvic acid. So that is also not a you can got your answer. But you, at first you collect your the authentified sample. Who is the authority? Give these yours that sample is the pure that is a good Shilajit. But that is the question because Rasa medicines actually Ayurvedic pharmacopoeia they are just take some the gradual action and their specification. But in CCRS, there is no explain the Bhasma. There is no special recommendation. But then Rasashastra nowadays is a good bioenhancer. But modern people, they take your just typical beauty. This is you are a Punarnava Mandur. This is the now US patient are take very properly. US modern doctor because they are ferrous sulfate they are taken. There is a constipation happen. But our Punarnava Mandur Bhasma preparation must be honest, and honest is the most important factor in Rasa medicine. You can just not a shortcut. Shortcut method is not possible. You just follow the traditional logic, also scientific question. So in that way, that Bhasma is past the gastrointestinal tract. That anemic patient they are take Punarnava Mandur, they are increase the hemoglobin level. But Shuddha Shilajit is the most controversial drug. At first, you collect the Indian market also, simultaneously the origin of also, and in that way you can build one protocol and one database for the Shilajit, and your MD or PhD in that is the good for the real data because Indian market now is the feasible. A fulvic acid was the most important parameter. But now chemically anyone add the fulvic acid. Next.
Thank you, sir. As a herbal drug technology used for converting botanical material into medicine, where standardization and quality control with proper integration of modern scientific technique and traditional knowledge is important. Ending with this, I request Dr. Ritesh sir for vote of thanks.
Sir, there is one question there. Hello.
Yes. Yes.
Sir, what does the VMD and SMD mean in the particle size distribution report?
Arna कुछ कह रहे हैं?
Actually, आपका voice echo हो रहा है. Actually, you can just ask question and another time. You can just question again.
Hello.
Yes.
So actually, we've written the question in the chat box.
Okay. You can ask your question. Actually, just how you would calculate your diameter. Yes. Hello.
So what is the difference between VMD and SMD and how do we interpret the data?
DMD. Actually, according to my lecture, what is DMD, SMD? Actually, I am not mentioned because this is a visualization technique. You can the ACM and TM and that but this is a XRD oriented or BTA, BAT or particle size analyzer. But that question I have not got it. Actually, what I was saying. This is a visualization technique or a basic reference the data. But I don't got it the question. Just I answer it. Any question? VMD and SMD. Actually, here is my presentation actually present.
Any question is there?
Hello.
Yes. Yes. No question now. This is the hello.
Hello, sir. Now I request Dr. Ritesh Ravnani sir for vote of thanks.
Thank you, Dr. Gunal. Thank you, sir. Am I audible?
Yes, sir, you're audible.
Yeah. So thank you very much, sir. Dr. Jayanta Kumar Maji, sir, delivered topic on cutting edge technique application and its interpretation in Ayurvedic medicine. So first of all, I am very thankful to Ministry of Ayush, Government of India. Then I would like to thank Honorable VC sir, Professor Sanjeev Sharma sir, their blessings and motivation always with us. Then I would like to thank Professor Anupam Srivastav sir, HOD Department of Rasashastra and Bhaishajya Kalpana, Professor Meeta Kotecha ma'am, Pro Vice Chancellor, Head of the Department Dravyaguna, and Professor Anita Sharma ma'am, Head of the Department Agad Tantra. Now I would like to thank our guest speaker, Dr. Jayanta Kumar Maji sir, for nice presentation and nice lecture. Now I would like to thank all faculty of Rasashastra Department, Dravyaguna Department and Agad Tantra Department. And I would like to thank all PG and PhD scholars for their patience listening, and also all listeners from different part of our country. I would like to thank all IT team of the NIA. And lastly, I would like to thank our coordinators, Dr. Karunanidhi Sharma, Dr. Akansha, and Dr. Gunal for nicely coordination of this program. Thank you. Thank you so much, all of you.